Hello everyone, my name is Sunita Gopavaram. As a part of the Sparks Foundation internship, I'm going to demonstrate first task of the data science and business analytics. First task is about the predicting the percentage of a student based on number of study hours. We are going to develop a simple linear regression which involves only two variables, hours and the scores. And I'm going to use R for building the model. Let's talk about a linear regression. The term regression means it is used when we try to find the relationship between the variables. We are going to find the relationship between the independent variables, the coefficients we are going to extract from the model, and we are going to draw build a line. With that line, we are going to get the outcome for the future events. This is the line that I was talking about. So we are going to build a line in such a way that it has an optimal bias and variance. So it accommodates maximum data points. So that's about a simple linear regression model. Let's go to the code. So this is the R Studio, and I have loaded the packages required. We have got CA. Sorry, we have got CA tools uh, and read Excel package which are required for our program. So I have loaded CA tools and read Excel. I have set the working directory to D and grip where I have all the files required for the program. So the data that I have like a student grade and scores .xlsx I have placed in the grip folder of the D drive, and I have imported the xlxs file using read xlxs file function, and I have stored the data into the student's data variable. We can view the data stored in the variable by using the view function. So this is the data of 25 observations and two variables, and we can observe the structure of the data that we have imported. We can cross check whether we have imported all the data correctly or not by using the head and tail functions. Head function gives the top 6 rows, and the tail function gives the bottom 6 rows. We can cross check with our data here. So we have the data in the Excel form, right? So we can see that 2.5 and 21 is the first row. So 2.5 and 21 is the first row. 1.5 20 is the sixth row. So we have got 1.5 20, and 7.4 and 69 is there. So when we scroll down, and we have seen 7.169 is there, and so now we have got 7.886. So we have got 7.86, 6.976. So we can cross check like this. As this is a small file, no need to cross check. But when we have very large data, we can use head and tail functions to check whether all the data has been imported correctly or not. We are going to split our data into training data as well as test data. We are going to build our model by using a training data, and we are going to cross check our model is predicting the output variable correctly or not by using the test data. So to split, we are going to use the sample.split function as a part of the CA tools package. So I have used the split ratio as a 0.7, and it is as per your convenience. We can use a 0.7, 0.3 or a 0.8 and a 0.2. And I'm going to subset the data into training set here, and whatever the training data that I have split, I can view that using the view function. So I can see all the 17 variables here. So the test data I'm going to put into the test set variable, and I can view the test data as well. And here we are going to build the model. The model is built like a linear regression model in R is built by using the function lm. and we can place all the dependent variable on the left side and all the independent variables we are going to place on the right side, and we are going to build the model using training set. So this is the simple function. We are going to build the model, and we can get the summary of the built model by using the summary function, and we can interpret the results here. Uh, the arts variable which we are using, that has 3 stars. It means it is statistically significant, and the p-value that we have got here is less than 0.05, which shows that this model which we have built is statistically significant. So we can this is the way we check whether the independent variables are contributing, how much they are contributing. We can get the intercept, and we can get the coefficient, and whether they are significant or not we can check here by using the probability, and we can cross check that with the plot function too. So here we have got a simple plot where we have odds on the x-axis and scores on the y-axis. As the number of odds are increasing, the score is also increasing. This shows that a score of the student is dependent on the odds. So we can graphically check by using the plot function. Now we have got the linear model. Now we are going to test that, cross check that with our test data. We have placed our test data in the test set variable. So let's predict the value by using the predict function, and whatever the predicted value, I'm going to insert a new column into the test set, and I'm going to store the predicted values into the predicted value column. So let's test that, and uh, let's view the test set. So here is the table. Here we have got the predicted values. Here are the actual scores. So when you see, when a student studies for 5.1 hours, his actual score is 47, and our model predicted the value score as 52. So when the student studies for 8.3, the actual score of the student is 81, and our model predicted it as 83. So there is a difference. This is the difference that we have got between the actual values and the our model predicted values. And in the question it is given that when a student is studying for 9.5 hours, what will be his score? By using the linear model, let's predict how much the student scores when he studies for 9.25 hours. I have stored the hours in a data frame, and I have assigned them into the new student variable. So when I am predicting that new student using the model built, and this is the predicted value. So I model is predicting that the student scores 92.6997 when he studies for 9.25 hours. So this is the way we are going to build a simple linear regression model using R. Using R. So I have imported whatever the R code into the GitHub. So this is my GitHub code, and I will share this link in the link below, so you can go through the code. So when we can import it into your R Studio, and you can run the model and cross check the results. Yeah, this is it, and thank you thank you so much for the Sparks Foundation for giving me this opportunity. Thank you all for watching my video.